So, ladies and gentlemen, you are welcome once again. And what we want to do now is to make sense of our sensitivity report. Okay. I want to first of all show you the sensitivity report. This is what we have. This is the entire sensitivity report we have. We're going to ask some questions and answer those questions right here. Question number one is a very simple question. You should be able to tell me the solution in a beautiful way. Using the report, what is the optimal solution to the investment problem? Raise your hand, I will unmute you, or type your question, your answer in the chat. What is the optimal solution to the investment problem? Okay. Let me go and take you through the sensitivity report now. What is the optimal solution to this investment problem? What is the optimal solution? Optimal solution. Okay. McClare. Let's see what I can.
Yes. Yeah. Let me try this and see. What if we invest 38,181 in treasury bill and 31,818 in stocks? That's stock.
No stock. That's it. That's it. Exactly the answer. That is how it is. So the optimal solution is, the key word to get clear here is that the optimal solution is a final value of the variable cells. Take note of that. Write it down if you have to. The optimal solution is a final value of the variable cells. And so you will say that the optimal solution to this investment problem is to invest 38,181.8 into treasury bills and 31,881 into the growth stock fund. That is your advice to the woman. Don't put your money into municipal bonds. Don't put any money into certificate of deposit. Don't do that. Of course, you're not going to advise them, but you're just going to tell the person what to do, not even what not to do. And you will appreciate later on why it has a reduced cost value, why they have a reduced cost value. So that's the first one. Okay. Now let's look at the second question. Okay. The second question. Find the corresponding maximum investment return. So we now know the optimal solution. What is the corresponding maximum investment return? What is the corresponding maximum investment return? Who can tell us? What is the corresponding maximum investment return? Who has an idea? The corresponding, how do you go about it, by the way? Okay. How do you go about that? The corresponding maximum investment return. Now let me show you in the situation that we're in. Okay, that took us to where we were. Okay, corresponding maximum investment. So the corresponding maximum investment return is asking you to tell me the final value of the total investment, And remember that we had certain things. We had X1, X2, X3, X4, each of them multiplied by their coefficient. But we now know that we should not deal with X1 and X2. We have to deal with what? X3 and X4. So all we need is the X3 and X4. So we need the last two here. They are the ones we need. And one is 0.065 and then 0.13. Okay. So that's what we are going to use to get the overall. Okay. So you get 0.065. 0.065 X3 plus 0.13 X4. Now we know the value of the X3 and then X4. Okay, we know the value, and the values are in the Excel, the sensitivity report. What is the value? The first one is 38,181.8. 181.8. Okay, let's deal with two decimal places. And when you actually take this, you realize that it will be equal to the total investment anyway. But let me just continue. 38,181.8. So you write that okay, 38,181.8. And then plus 0.13 times the next one, which is the X4. And when you go to the Excel, you'll notice that X4 is 31,818.2. Okay, 31,818.2. So you take your calculator, okay, and then you now find the solution to this. Who has gotten it? Okay, you now find the solution. To be honest, when you check it carefully, you will see that that will be the total investment. Okay, that will be the total investment that was made. Approximately the total investment. Did you confirm that? Who did a true confirmation of that? Okay, because when you do that, you will notice that that will be the true confirmation of that. Okay. But it's always good to use your calculator to find the actual answer. But that will be the total confirmation. And I know that, and you might know that because if you check the sensitivity report, okay, the last constraint was AMA wanted to invest the entire amount, if you can remember. That was the last constraint. Look at that constraint here. You can see that the right-hand side is the available $70,000, and the left-hand side is a used $70,000. So again, you can see that the whole investment was used. All available investment was used. And technically, when you look at 38,000 and then 30,000, okay, that is about 69,000. And when you add these other elements to it, plus the little decimals of the interest rate, you see that that will be approximately the 70,000. All right, so that was a question that was the maximum amount. Next question, was the entire amount of money actually invested? This is easy, who can tell me that? Was the entire amount of money actually invested? Who can tell me? Of course, with the was the entire amount of money actually invested? Let's go to the Excel. Okay. Was the entire amount of money actually invested? Who wants to give me reason? Was the entire amount of money actually invested? Who want to raise a hand and then explain? Well, the answer is, oh, good. The answer is yes. It can never be no. It's yes. The entire amount of money was actually invested. And this is the reason. Because the last constraint said, AMA want to invest the entire 70,000. And look at the entire 70,000. That's on the right-hand side in the constraint 5. And yet, the final value of that is the usage. Okay. Remember, the final value is also 70,000, which means that everything was used. Everything was used. And that is why. Okay. Some people are very quick at writing the answer when they see me now explaining it. Okay, Maclay, you have a question.
Yes, sir. Not this question, but the question before that, talking about the corresponding maximum distance. If you slot those two, this in the final value, that's for the variable cells. The last two, if you slot it in that formula, I'm getting 6,618 as the Z max.
Oh,
because we're multiplying by 0.0865, not
okay,
the 70,000 that we see.
All right, that's very good. So let's do it together. To be honest, otherwise, so we need to question this amount. Okay, let's be clear with that. So you take your calculator. Let me see what I can show the calculator here for all of you to be with me. Okay, so this is a calculator. I'm sure you all see it. Okay, and then we had the symbols. What were they? We had 0.065. Okay, so 0.065 times 38,181.82. That gives you 2,000. That's true. That gives you 2,481. Okay. 2,481. Let me write that. 2481.8. So you go to your computation. Let's delete this. Okay. That gives you 2481.82. 2481.82. So that is the amount we had for the first one. Then plus, go to a calculator again. Okay. Let's clear the situation. And it is 0.13 times 1,818.18. And that gives you 4136.36. Okay. 4136.36. So you get 4136.36. And so when you add this one, so it's all right. I mean, it's all right. That's how I got to check. When you add that one to the amount we had, what was the amount? The amount we had was 2481.82. Okay. You get 2481.82. You get 6,618.18. Okay, so that is the amount that we finally get for the maximum. 6,618.18. So this is rather the maximum amount of returns, investment returns. The point is the investment return, the total return that you have, not the total amount invested. As for the total amount invested, it was 70,000. But the total maximum return that you retrieved was 6,618. So it means that you put in 70,000, you got about 6,600. So you made some extra 6,600. Thank you very much, Maclay, for the wonderful, wonderful interjection right there. So at this stage, we are now ready to go to our next question. And the next question was, so we've already answered this, was the entire amount of money invested? Yes, because the usage of the amount was the same as the available. What is the sensitivity range for the amount of municipal bonds? What is the sensitivity range of the amount of municipal bonds? Let's go and get that. It's very important to appreciate this. Okay. Now, municipal bonds was the first one, X1. So this X1 here, the sensitivity range. How do we calculate the sensitivity range? This is just a recap. If you check the previous videos, you will notice it, but this is just a way to recap. Okay. The sensitivity range for municipal bonds or any other thing is given by this range, where you have the lower bound and then the upper bound. Okay. Now the lower bound is actually the objective coefficient plus the allowable decrease. Let me show you that first. Okay. The objective coefficient plus allowable decrease. So if you look at any particular coefficient, it has an allowable increase and allowable decrease. Okay, allowable increase and allowable decrease. Now the objective coefficient minus the allowable decrease is the lower bound, and I hope that's what I wrote. Okay. Okay, so it's minus. The objective coefficient minus, not plus, minus the allowable decrease is a lower bound. And then the next sensitivity will be the objective coefficient plus the allowable increase. So go and take your objective coefficient, subtract the allowable decrease from it. Now, what is our allowable decrease? What is our objective coefficient in the first place? The objective coefficient for municipal bonds is 0.085. What is our allowable decrease? The allowable decrease is 1e plus 10, 30. What does that mean? This is simply infinity. This is simply infinity. So in principle, and this is what you want to understand, okay? Watch me. In principle, the objective coefficient is 0.085 minus infinity. That symbol there is infinity, which in principle, that is going to give you like what? That's going to give you like negative infinity. But you have to understand in principle that anytime you have a negative number, round it to 0. Now, the reason why you got to round it to 0 is that interest rate, this interest rate that we are talking about, cannot go into negative infinity. It cannot go into negative infinity. And most of the time, it hardly happens that we will even have some of these things to be negative in real market systems. Okay, so you can easily round up. Anytime you have those negative values, you can round them up into, especially you have negative infinity, just round it to negative. I'm going to explain to you what this means. Okay. And then the next gap, of course, the next gap for this one will be the objective coefficient, which is 0.085 plus the allowable increase. Go and check the allowable increase. The allowable increase is 0.045. 0.045. So you add that 0.045 to the objective coefficient. So you do plus 0.045. Okay. And once again, if you take your calculator, okay, because that's where you got it go. You take your calculator, you do 0.085 plus 0.045. That will give you 0.13. And so this is less than S municipal bonds, less than 0.13. So the upper bound of the municipal bond is 0.13. The lower bound is 0. What does that mean? Well, currently, the municipal bonds, the interest rate attached to it is 8.5%. Do you remember? You remember, exactly, 8.5%. Now, according to the sensitivity range, as long as you change that interest rate of 8.5, changing means that you can increase it or reduce it, but don't reduce it below 0. That's a limit. Don't increase it above 13%. That is the upper limit. As long as it is dancing between the 0 and the 13%, as long as it's within the sensitivity range, the optimal solution will not change. What is optimal solution? The optimal solution, let me take you to the Excel. The optimal solution is to produce these treasury bills and the growth stock fund. That optimal solution of this production will not change. It is not going to change as long as you are within the sensitivity range. Okay, so as long as you're within the sensitivity range, the optimal solution will not change. But as soon as you exceed that sensitivity range, as soon as you exceed or you go below, then the optimal solution would what? Would change. So if you try to increase the interest rate from 8.5 to 14%, what is going to happen is that you're going to cause the optimal solution that we had, all of it to change. But as long as you're within, it's not going to change. So that is it. You can calculate the sensitivity range for all the others. Okay. And the gap, the range should tell you that you can't increase, the objective coefficient. You cannot increase these objective coefficients. These are the objective coefficients. You cannot increase or decrease them more than the upper bound or less than the lower bound of the sensitivity range. That's the interpretation of it. Okay. Now let's look at the next question. Which diversification mix will yield the most return? Now the diversification mixes are the constraint. So constraint one is a diversification mix. You are supposed to contribute 20% of this into that, this percent of this into that, this percent of this. Okay. The question is actually which of these, diversification mix will yield the most return? Who can guess? Which of these diversification mixes will yield the most return, will give us the highest Z value, the highest return? And once again, if you have taken your time and have watched the previous video, you will see that the only way to answer that is to use the shadow price. The shadow price. You see, the shadow price will tell you by how much the Z value, the objective function value, will increase if you should increase the right-hand side by 1 unit. In this case, if you should increase the right-hand side by 1 unit, okay, what is going to happen is that the Z value will increase. Look at the value of the shadow price for the last diversification mix. It has a shadow price of 0.09. So it means that the Z value is going to increase by 0.09 if you should increase the right-hand side of 70,000 by 1 unit. But if you look at the next one here, if you should increase this diversification mix, that complex ratio diversification mix, if you should increase it by 1 unit, the shadow price is saying that the Z value will fall because there's a negative value. As for the others, even if you increase them by any amount, the shadow price says that the Z value will not change. The Z value is never going to change. So there is no need to touch them. And therefore, the diversification mix that will yield the most return is obviously going to be the last one. Okay, that will give you the best and the most performing diversification mix. And it's the one with the total investment because it has the highest shadow price. Now let me ask you this question too. Which constraints are binding? It's a very simple question. Which constraints are binding? Let's look at constraints. Which constraints are binding? Can somebody tell me which constraints are binding? By the way, the constraints are said to be binding when the left-hand side is equal to the right-hand side. When the left-hand side equals the right-hand side, we say the constraints are binding. When the final value of the constraint is equal to the constraint right-hand side. So which constraints are binding? Constraint 1, 2, 3, 4, 5. Which one is binding? Which one is binding? Which one is binding? Let me see some of the answers. Okay. McClure says constraint 5 is binding. That is true. That is not the only constraint that is binding. Constraint 4 is also binding. Okay. Constraint 4 is binding. Constraint 5 is binding. These are the only binding constraints. A binding constraint means that there is no slacks. Keep that in mind. It means that there is no slacks. A binding constraint means that there is no slacks. And it also means that there is a shadow price. There is a shadow price. An absolute value of a shadow price is there. So these are the binding constraints that you can think about. Now let's go to the next question. The next question is, if AMA has a choice of investing in municipal bonds or certificate of deposit, which is she going to choose and why? Now remember, the municipal bonds is represented by the X1 and the certificate of deposit is represented by CD. But that statement, municipal bonds or certificate of deposit, the best way to appreciate and understand that constraint, it's talking about a constraint, is to go back to your formulation. Go back to your formulation. Let me show you that formulation. Okay. Do you remember the last formulation? The last formulation, this one. Okay. This last formulation it was municipal bonds is the first one, which is X1. The second one is certificate of deposit, okay? Okay, so that is X1 and then X2. But this one we are seeing here is X2 and X3. So let's go to our constraint. There was a constraint that we had. Okay, where is that? This is another constraint that we had. Okay, and then this. Okay, so let's go back to our Excel. Our Excel. So let me read the question again. Oh, the question says that if AMA has a choice of investing in municipal bonds, which is X1, or certificate of deposit, which is X2, which should she choose and why? Who can tell me this? This is fairly simple. Okay, municipal bonds or certificate of deposit, which one is she going to choose and why? Which one is she going to choose and why? Who can guess? If AMA had a choice of investing in that, which one is she going to choose and why? Which one is she going to choose and why? It's none of them, exactly. It's none of them. Because the municipal bonds gave us a value of what? 0. And then the certificate of deposit also gave us a value of what? 0. Which shows that we should not invest in them. So the question is actually, which one should she choose? The answer is none of them. None of them, because they yield nothing. This is the solution. Nothing was invested in the two assets in the optimal solution. Okay? Nothing was invested. So how much would return for this product have to be for it to be invested in? So the answer is that don't invest in any of them because nothing was invested. Now here's a question. A very last important question is, I did not invest in municipal bonds. AMA did not invest in municipal bonds. AMA did not invest also in certificate of deposit. Why? Well, partly the reason is this. Let's go to the Excel. The reason why AMA did not invest in them is because watch the coefficient. Okay? According to the coefficients we are having, there is an 8.5 interest rate and there's 5% interest rate on them. And so this interest rate wasn't that much. It wasn't that much to invest in those ones and given their value. And so that is why he didn't do that. So what should be done for AMA now to be willing to invest in them? Well, what you want to do is to increase the shadow, the objective coefficient, increase their value, increase their objective coefficient. So you have to increase the interest rate 8.5 up to what limit? Who can tell me? Increase the interest rate of 8.5 up to what limit? Up to the upper bound of the sensitivity range, which when we added the 4.5% to the 8.5%, we had what? We had a 13%. So for AMA to actually be willing to invest an amount, not 0, but an amount into municipal bonds, increase the interest rate to a minimum of 13%. And in fact, you can check it later. If you go and change this value in the Excel, and then you put something like 13% or even 14% there, you will see that the value here will change to positive and not 0. In fact, one way of answering that question is to do this. Look at the value for the objective coefficient. I'm going to work it for you here. Look at the value for the objective coefficient. Okay. The value for the objective coefficient is 0.085. Okay. Now, what will make me now produce X1, make it positive? Okay. For that to happen, I need to add the objective coefficient, okay, and subtract the reduced cost value from it. That is how you will get it. So for me to produce, for me to make the municipal bonds positive, I need to have The objective coefficient here is 0.085. I need to do minus the reduced cost and check the reduced cost value for municipal bonds. It is minus 0.45. So you just go and then do minus 0.45. And when you check it, it will be plus. And that plus will mean that we'll come back to 13%. Okay. So it means that you need to price that 8.5%, push it to 13%, and this becomes what? Producible or investable. And that is the principle of sensitivity for that very one there. Okay. I know it's a little bit complex, but when you go, you check it, you do. That is how much to be. But when you go to the other one, let's go to the other one, which wasn't invested in. What was the other one? The other one was what? Was certificate of deposit. Its interest rate was 5%. So once again, if you want to be able to invest in it, do 5% minus 1.5%. 5% minus 1.5%. And when you check it carefully, that will be the upper bound of the sensitivity range, which is the same thing. Okay, when you add this 1.5% to this 5%, you get 6.5%. So it means that increase it to the maximum value of the upper bound of the sensitivity range, and that is when this one becomes producible. I've explained all of this already in the Farm Milk Ghana Limited program, but I'm just giving you, details of that. So once again, anytime the final value is 0, the reduced cost value will tell you that the reduced cost value will be positive or negative. Anytime the final value is 0, if it is maximization, the reduced cost value will be negative. If it is minimization, the reduced cost value will be positive. But anytime the final value of the variable cell is positive, it means you are producing that final value. And what it means is that the reduced cost value will be 0. Of course, you should know that the reduced cost value is the opportunity cost of producing the final value. The reduced cost value is the opportunity cost of producing the final value. Now, finally, so everything I worked is in your slides. You can check it. And then this is how we calculate it. Next time, you will look at another example, which is known as a marketing example. We'll look at that marketing example that will stretch us to be able to better understand the sensitivity ranges. Go and try it at home. And then when we meet next time, you will love the situation. Once again, remember to drink deep or taste not the Pyrenean spring. Their shallow trouts will intoxicate your brain and so that's us. What an evening. What a day.